chemistry. Thank you for bringing that back. Yeah. Let's learn the formula for water today. Yeah? Okay, so, silencio por favor. For the charges, how do you find the charges of metals and nonmetals?
Look at the
valence of electrons, you figure out if they gain or lose electrons, yeah? Well, that's basically it. So, oxygen, what's its charge?
-2.
-2. Fluorine.
-1.
-1. Beryllium. +2.
+1.
Potassium. +1. So everything in group 1, 2, so this is a +1, +2, this group, +3,
Plus or minus.
+or -4, -3, -2, -1, 0. Okay, what about the stuff in the middle?
Oh, we don't know.
We don't know yet. We're going to learn today. So the transition metals have variability in what they can kind of do with their electrons, because they either have, like, for example, zinc. What's its tail part of its its electron configuration? It goes boom, 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 boom. So what is it? Tail part.
You know.
1.
What's this one?
1s2. Oh, sorry.
4s2.
3d10.
3d10. So actually, zinc loses the valence electron 2, or 2 valence electrons, so it becomes zinc 2+. But sometimes they act funky and they choose to lose, 2 electrons this time, but then like 3 electrons this time, and then like 4 electrons this time. So they have variable numbers of charges. Yeah.
So like every
10th. This one.
Sorry, every transition metal is 2+.
Not every transition metal. Sometimes they form 2+, sometimes they don't. That's why I say they're variable in what they can do. So we're going to learn how to denote that today. Because if I say sodium, I don't have to tell you it's 1+. You know, because it's always a 1+. If I say nitrogen, I don't have to tell you it's a 3-. It's always a 3-. So, but if it does have differences in what it can become, you have to literally say it out loud, because I can't read your mind, nor could you read my mind. So you have to write it or say it. The way that is denoted, well, actually here, write down these charges first, and I have to add a couple of extras. The way it's denoted is by Roman numerals. We're going to get there. Zinc, like I was just telling you, always has a 2+. That one doesn't have any variability whatsoever. So this one's always a 2+. Silver is always a 1+. Cadmium's always a 2+. Those are the only ones that have constant specific charges associated with them. Then we got these ones that have some room to play. And I have to add 2 more here because I don't have them up here. It just takes a little practice to get the hang of these. And I'll kind of explain to them via electron configuration for you too. So write this on your periodic table, notes, wherever, okay? Because we're going to use these a lot. So tin has a 2 or 4+ charge it can take. But notice that tin is not actually a transition metal, like a true D-block transition metal, but they act like transition metals. So lead and tin are over here. What is their electron configuration? Like the last part. So you would go da-da-da, da-da-da-da-da, da-da-da.
5s2.
5s2.
4d10.
4d10.
5p2.
5p2. So that's the tail part of zinc, right? I mean, sorry, what's this called? Tin. So tin has either a 2+ or 4+. Where do you think that's coming from?
The 5s2 and the 5p2.
Right. So either it loses only 5p2. When it loses 2 electrons, what's its charge?
2+.
+2 charge, because you lost 2 electrons, 2 negative charges. Or it can lose this one and this one to make it a +4. So I'm not making these numbers up. There is a method to the madness. I'm just not going to explain every single one of them because you don't really need to know that. You just got to practice it and you get it. But that's why zinc and lead. So lead can either be a 2+ or 4+ as well. Cobalt is either 2 or 3, and it's because it being in the middle of the transition metals here in the D block has some room to play with all those d orbitals to move around electrons. Iron is a 2 or 3 because it's the same situation. And then, is there any more that I need to talk about? Oh, copper. Copper, being here, can lose D block electrons and or S block electrons. So all of these are different because they have different colors and different properties. So for example, you saw in your flame test lab, do you remember what color copper turned whenever it went in the flame? Greenish blue, right? So copper either is, copper 2 is blue, that's how I remember that, copper 2 is blue, kind of rhymes. Copper 1 is green. Iron it had a gold and green tint to it whenever it was doing the flame test model. So it actually has a yellow ion, which is the iron 2, and then has a green ion, which is iron 3. So that's where the colors come in for color chemistry and transition metal chemistry. Yeah.
What determines whether or not, whether it's like +2 or +3?
It depends on what other compound is around to take the electrons. If you can take 2 electrons, it will. If you can take 3 electrons, it will. It just depends on what it's bonding with. So let's talk about the bonding part. Let's do ionic stuff. So the ionic stuff we did yesterday, let me like do 2 more, one of each, the polyatomic and the normal stuff, and then we'll do transition metals. So, oh no, I'll come right back to this. So we did these first couple yesterday. I'm gonna scroll to the bottom. Did we do barium acetate? No. Okay, you guys have your stuff from yesterday. Just write on your papers for us, okay? So let's do number 12, barium acetate. So barium has a Ba symbol. What's its charge? I want your periodic table out. Shout it out. 2+, thank you, loud and proud. We're a big happy family here. It's cool. So 2+ for barium. Acetate. That doesn't even sound like an element. That sounds like a polyatomic ion because it's got the 8 ending right there. So acetate.
C2H3O2 1-.
Okay, so what do we do with polyatomics? Parentheses, right, because you don't want to mess up. This C2H3O2 acetate is a big happy family. Do not break that family up. Don't be a family murder, okay? You want to keep them together. So we have barium 2+, acetate 1-, crisscross, applesauce. What do we get? Ba, parentheses, C2H3O2, end parentheses, 2. Okay, so you would call that barium acetate if you saw that, on the screen. Call it barium acetate. All right, so let's do one that doesn't have a polyatomic ion, just a normal plain old "-ide" ending. So I'm going to come here. So this one, notice that I have a little extra. I got a middle name going on here. This is describing lead, because lead is a transition metal. What are the 2 possibilities for lead's ion charges? +2 or +4. If I just say lead, then you got to go, so which lead are you talking about? Because you have no idea if I don't tell you. So how do I tell you? I write 2. Or I can write a 4 there, but that's lead 2. So that means Pb 2+, and then phosphide is what? Just phosphorus, just plain old phosphorus. What's its charge though? -3 because it's in the 5A and it gains 3 electrons to be like noble gas electron configuration. So lead 2, phosphide, crisscross, you get Pb3 P2. I'm not going to draw the crisscrossing all the time, but for those people who weren't here yesterday, all we're doing is taking the charges and we're crisscrossing them to subscripts on the other ones. And if you're sitting next to somebody, they'll help you. They'll hold your hand if you need to. Okay, so we got 2 different examples. I'm going to go back to the transition metal notes, and you guys can write down what you need to. So the transition metals have 2 different ways to tell you its charge. Literally writing the charge as a Roman numeral, and I'll tell you the other one in a second. So the first way is called the stock system. It's because in the stock room where I keep all the awesome chemicals, we have to write it this way. So if I just say tin chloride, and Mr. McNeil back there, he would yell at me because he's like, which tin is it? Tin 2, tin 4, what is it? You have to tell somebody. So the way you write it is tin 2 or tin 4, whatever you want to do. And that just helps you to denote from those transition metals what the heck you're talking about. So that's tin 2 with a 2+, chloride 1-, crisscross, what'd you get? Good job, tin 2 chloride, SNCl2, okay. So lead 4, notice this is a 5 Roman numeral -1, so 4. So it would be Pb4, sulfide is what? Okay, charge -2, crisscross, what do you get?
Pb2S4.
Pb2S4. You think funky with that one. Right, if you have the option to reduce it, please do so. It's called the empirical formula. It's supposed to be the simplest ratio for a particular ionic compound. So this is reducing to what? PbS2, good. If you solve that, you have to, in your mind, uncrisscross and assign the charges. But if you uncrisscross, what does this actually look like? This looks like uncrisscrossing Pb what? This 2 comes up there, right? And the S gets a 1. If you uncrisscross and you see that the sulfide does not have its normal charge like it should, that means that should tell you, oh, this thing was reduced before I got to it. So then you'd have to go back and go, oh, that wasn't Pb and 2 and S1 minus. That was previously S2 minus and Pb what? 4. So when you name it, you have to go back to what its original was to go Pb4 or lead 4 sulfide. We're going to practice that because that one's just a 3-step process. Okay, so that's literally saying it in Roman numeral form what the dang charge is. Sometimes we go back to way back when we didn't have these fancy, charges and stuff to denote our symbols. So we have to use the classical system. The classic times, way back, they used these suffixes, os and ik. So write down what you need to. And I'll give you an example. I'm going to eat this thing that Miss Covalent's brought me. Maybe. I trust it. Food supplies.
What is it, cinnamon roll?
It's a cinnamon. It looks delicious though. So I'll eat this one.
We made our dough yesterday. We're supposed to make them today.
You can bring me one. I'll be your guinea pig.
Maybe. We'll see if they turn out with it.
That's good. So having the two different suffixes, os and ik, will actually indicate to you which ion you're talking about. And this also gives us a little insight on where did they come up with Pb for lead. Doesn't even have the same letters in it. Where did they come up with Fe for iron? Doesn't even have the same letters in it. Well, iron used to be called ferrous and ferric. That's an F. Okay? Ferrous and ferric. So ferrous gave it the Fe symbol. That's like what it used to be called way back. But these are the two versions of iron. What were the two versions of iron? Iron what and iron what?
2 and 3.
2 and 3, right? So the low, ferrous, low, I don't know, I just have to come up with silly things to make myself memorize it. So ferrous is the lower number. So of iron, which is the lower number? 2. So ferrous is saying Fe2+. And ferric sounds like it's happy and it's a higher number, right? So this one's a higher number. This is what I do to myself to make me memorize it, just like you guys have to. This is iron, higher number 3. All right, so another one. Let's do cuprous. Who do you think this is?
Copper.
Right, cuprous and cupric. Sounds like I'm calling it prick. It's cupric. Okay, what's this? Low, copper low. Right, this copper has 2 charges, 1 and 2. So this is copper 1+, and this is copper 2+. Let's do another. I don't know what this little thing is here. Okay. Plumbose and plumbic. Lead, right. That's where we got the Pb from. It's from the plumbus word that they used to have. So which is the plumbus version?
2+.
Pb 2+, and this one's Pb 4+. It's just you have to know the charges to know which these are. This one's harder because you have to know the charges. This one's easier because I literally give you the charge. So it's just, you'll see this one like for the classical system, like 1 out of every 10 problems. You'll see this one like every 3 out of every 10 problems. You'll see this one more often. All right, so let's practice this one again. Let's do number 5, cobalt 2 hydroxide. So cobalt is CO, this 2 is saying cobalt's charge is 2. What's hydroxide?
OH minus.
OH minus, and that's a polyatomic ion, so I put parentheses around it. The charge goes on the outside of the parentheses. Crisscross, what you get?
OH2.
Parentheses, OH2. Because if you tell me parentheses, that means I believe in you. I trust you. You could teach this for me to people who aren't here today. Okay, so I want you to make sure you tell me parentheses when you need to. So this is denoting there are 2 H's and 2 O's, which is totally different than writing this. This says there's only 2 H's, there's 1 O, and there's 1 cobalt. That's what you have for parentheses, because if not, it's totally not even the same thing. So it's definitely wrong to write it this way. Okay, let's do another one with transition. Which one do we not do? Chromium 3 oxide. Yeah.
So could you write it out if you distributed?
Don't distribute, because that actually makes your balancing work a lot harder when you get to it in our next unit. So it's actually easier to keep it as a parentheses. Just it's in your best interest. Okay, so chromium 3 oxide. Chromium 3 oxide is what? What charge? 2 minus crisscross, you get Cr2O3. So if you didn't know the name, if you had to look at that chemical formula and name it, what you would have to do is go, first of all, metal, non-metal, right? So what does that indicate to you? Ionic. So if you say ionic, you have to find their charges. You have to, and that's how you're going to get the 3 plus for chromium. So when you find their charges, you uncrisscross and go, oh, well, that was chromium 3 in oxide, so that is chromium 3 oxide. Okay, so that's why you have to be able to go back and forth, back and forth. Let's do one more just for kicks and giggles. Yeah.
Will the Roman numeral always be positive?
Yes, because metals always lose electrons. They'll always be cations. Yeah. Nickel 3 thiocyanate. All right, so I got you here. Nickel 3. Okay, thiosulfate, not thiocyanate. S2O3. Right. Now that one does not really have any method to its madness. Thiosulfate and thiocyanate, they're more upper level polyatomic, so we just have to kind of go with the flow on that one. But that's S2O3, 2 minus crisscross, you get 2O3, 3. Okay, let's go the other way. Let's go from name to compound. Ready? That's on the other side of your sheet. So I'm hoping that you're doing some of these with me so that you have some good examples to go back for problem set 9, which is not due tomorrow, by the way. It says it's due tomorrow. It's not. It's due like Thursday. Okay, this one. This is a polyatomic ion. How do I know that? Parentheses. Which of those is it? This is the only one that's a cation of the polyatomic list.
Well, that's ammonium.
Ammonium, right. This is ammonium. And then the last one, there's only 2 names here.
Sulfate?
Sulfate, right. So I don't always put parentheses around it, but if you need them, please give yourself parentheses to go that sulfate. It's just 2 names. Don't try to give it a middle name. Don't try to give it a prefix, suffix, surname or something. It's got a first name and a last name. Ammonium sulfate. So notice you said 8 on the end, which is the polyatomic ion ending. Next one. 2 names, blah, blah. Calcium, I hear you.
She's on this phosphate.
Phosphate, good. So phosphate is a PO4. What's the charge on phosphate? Don't look. Look up here. What's the charge on phosphate? How did it get changed?
3 minus.
Right, because that is actually calcium 2 plus from this 2, and this is actually a 3 over here, so that was phosphate with a 3 minus. So you don't have to always look at your list. You can figure out those things from the compounds given. All right, so it's calcium phosphate. Next one, simple, easy one.
Calcium oxide.
Calcium oxide. Okay, so you should see a difference. Usually polyatomics have the 8s endings, and then normal periodic table nonmetals, just normal stuff, you just have an "ide" ending, like sodium chloride. That's just a general one we've always used. All right, so this one you can already determine what's the ending going to be. Ending. It's going to be carbonate, right? It's going to have an 8 ending. So the whole name is lithium carbonate, because you're looking at the polyatomic ion as its ending, at its ending. All right, let's keep going. Let's keep going through a couple more. And I have to fix one of these. I think I have a typo and I have to fix it. My first period. All right, this one, everybody.
Potassium bromide.
Potassium
Bromide.
bromide, right? It's a simple anion, just means an "ide" ending. So potassium bromide. Okay, and I'll tell you the difference on one of the sheets you guys have to do. You have to write, I'll tell you that later. So you have to write binary, ionic, and ternary, but I'll get to that shortly. All right, this one I had to change because I erased the wrong thing on y'all's. Write this one out, CaCrO4. I think I put C2O4 on yours. I erased the wrong number. So this one, see, it looks like there's 3 totally different ions together, but it's only 2. You only get to have a first name and a last name. So you have to break it at the middle. The middle is first. Everything else is the last name. Yeah.
Wait, wouldn't it just be the calcium oxalate?
On your paper, it's calcium oxalate, but I've used oxalate a lot, so I wanted this example. This is not oxalate.
Okay.
This one's different. So calcium is good. Yeah, I accidentally erased the wrong one on y'all's and the one I put on the board. So I took the 2 out, so it's CrO4 for you guys. All right, so what is the CrO4? What polyatomic is that?
Chromate.
Chromate, right. So calcium is a 2 plus. Chromate is a 2 minus. What happened? Why are there no 2s? Right, they reduce down. Because if you say they cancel out, sometimes that makes me think they're not there. They're there still, they're just what? They reduce down. I know, I'm picky. Sorry. Okay, this one. What's the first name?
Copper.
Okay, so copper. This one has kind of a middle name. Okay, I do like the dichromate, so I'm gonna put copper and I'm gonna put dichromate as the last name. But there is a middle name on this one only because it's a transition metal. It's a really short numerical middle name. Two. Thank you. It's only this because it's a transition metal. And if I say copper, you say copper 1 or copper 2, Miss Inlow, I need to know. So that's why you have to tell me which copper it is because it's one of those variable ones. Let's do another one like that. So tell me which one. The next one is going to have a Roman numeral. Iron, right. Number 9, iron. So iron what, though?
3.
Why,
Oh,
why
wait, no.
3?
No.
You gotta think about this one for a second. First of all, how about you tell me what the second name is?
It's carbon.
Okay, so that's carbonate. And there's a middle name. We definitely know there's a middle name. We know that's got a number. But that is not the subscript of charge. That subscript is the happy family of carbonate. So what's on the outside of that? Why dose? Right. Carbonate is a -2. You cannot change its charge. That means that before we did the whole formula thing, we had iron, I don't know, carbonate 2-. And so when we crisscross these, I'll get your question in just one second. When we crisscross these, it was iron 2, carbonate had to be 2 because we reduced down to 1 and 1. So it's how you know it's iron 2. That one takes like a 3-step process though. Question?
Yeah, can I go back to number 7?
Yeah.
What do you do with the oxygen one? Is it heptaoxide?
This is not oxide because that would give it a third name, right? This whole shebang is dichromate. That is the whole polyatomic. So if I put parentheses around this, that's the dichromate polyatomic. So that's all you have to say for Cr2O7. But the oxide one, we just had an example like that. It's just a simple, I don't know where it was, that one oxide, just simply O. So that's why I'm trying to give you guys some tools, some skills to use. Breaking it up into first and last name. You always break it after the metal, the first metal. You'll never have 2 metals next to each other.
Usually only has 2 names.
Yeah, usually has 2 names unless you're a transition metal and you have the little number between them. Okay, so let's do this one. All right, so I got you first. Iron. Number 2, because this 2 did belong to iron, and this 3 did belong to phosphate, right? So that makes sense. There's no fishiness there. So iron 3 phosphate.
But not 2.
I mean, sorry, iron 2. I just looked at 3. Thank you. All right, next one, 11.
Nickel.
What'd you say?
Nickel. Or nickel 2.
Thank you. Where are we putting 2 here? And yeah, this 2 came from nickel, and nickel's a transition metal. Nickel does have some options. It wasn't on your original list because the ones I gave you in the original list are just the most common ones. But anytime you have a transition metal, you have to put the Roman numeral, except for zinc, because zinc's always a 2. You don't have to tell me. I got you. Silver's always a 1. You don't have to tell me. I know that. And then cadmium's always a 2. You don't have to write that because there's no other options for it. So it's nickel 2 chloride. Now don't go like crazy putting Roman numerals on everything. It's only for transition metals. So let's bounce back to a simpler version. Let's go to number 13.
Aluminum.
Aluminum, what?
Phosphide.
Phosphide, right, because phosphide is it's not a polyatomic ion, so it doesn't have the 8 ending. It's just aluminum, and then a normal non-metal, phosphorus, which goes to phosphide. So the endings are changing on all the anions, okay? We got 8s, we got ites, we got ides, we got ems. Yeah, I think that's it. So let me show you how to kind of make the pattern in your head on how to actually remember the polyatomic ions, because it does take a little effort, but I have some tricks for you. You ready? The tricks are, I'm going to scroll all the way back to my first page, and I recommend you write some of these examples down. From here. I'll have to, let me get myself a little extra page going on here. Okay, why is there an eraser? Okay, so everybody tell me chlorate. chlorate?
ClO 3.
3, 1 minus. Okay, so chlorate is that. What's chlorite? Okay. What's hypochlorite? ClO1, right? 1 minus. What's perchlorate? Okay, ClO4, 1 minus. So if you go between an H and an ite version of the same polyatomic from here to here, what happens? You lose an O, right? You just lose 1 oxygen. Why would, so 8 to ite, if you remember the 8s of every polyatomic ion, you don't have to memorize the ites. They just kind of fall into place because you know you drop an O. So you're memorizing half of those and then understanding the pattern for the other ones. That's basically it. But we'll work on that. It takes a lot of practice to get really into that. So we will slowly make progress on polyatomics. How, when I go from ite to hypochlorite, why does that make sense to drop another O? What's the prefix hypo refer to?
Lacking.
Lacking, below. Who's heard of hypodermic needles? It's my best example. They go below your skin. Yeah? Nobody liked my example in the first one, but I'm like, that's wrong. So hypo is below, okay? So below means you drop hypothermia or hypoglycemia, hypotonic solutions, lower concentrations. They got hypo is all over the place, okay? So hypo means below. That's why you drop another O. The one that has a per prefix, I used to call it hyperchlorate, but per is the better way for it. I just remember per plus 1. So I'm just trying to give you my little tips and hints on how to get from the 8 version, which is one you can memorize, chlorite, you drop an O, hypo, you drop another O, but if you have a perchlorate where you have the 8 version but you still have a per in the front, you add an O, so you have ClO4. So if you can remember this one, the rest of them kind of fall in place. Does that make sense? Yay, nay? Okay, so what if I said, here's my formula for phosphate. Here's the formula, PO4, 3 minus. What is phosphite? PO3, 3 minus. What if I give you, let me go further. What if I gave you bromate as BRO, 3 minus, and I want you to give me bromite, 2, 1 minus. It works every time, okay?
How come, like, if you, there's different proportion. The same charge.
It's based on something called formal charge, which is an AP level concept, but that's why. There is a method to the madness, but I don't want to explode your brain yet, but you can take AP Chem. Ask me that in the year. Okay, we got these. 8 ites, hypo, per. Oh, and then I just gave you an example. Em only occurs with 2 of the polyatomic ions, ammonium and hydronium, which we won't talk about really this unit. Ammonium is NH4, 1 plus. That's just the only cation version of the polyatomics, really. And that's another one, but we'll talk about the acids and bases. And then the only 2 ide versions, which generally, ide means look at the periodic table and get your charge. Generally, that's what the ide means. But in this case, hydroxide and cyanide are 2 examples that we use a lot with polyatomics, and they are not from the periodic table. They are their own entities. So what's hydroxide?
OH minus.
OH minus, and what's cyanide? CN 1 minus, right. So those are the 2 that are kind of off and oddballs. They don't fit the trend. All right. Take a stretch break for a minute. You guys are getting sleepy. Stretch break. Go hug somebody, say hey. Tell them what they're doing for the weekend. And I'll do covalent. Ask Clayton how their math competition was yesterday. I know Connor. Sorry, Colin Connor.
Like you need a hug.
I answered quite
That's impressive. I've heard that stuff is really hard. Like, I'm being serious.
Just standing, didn't say anything.
I've heard it's really hard.
Yeah, and will you leave a little bit of room? Because I have to do it for my third period too, since I'm not currently in leadership.
Yeah. So I just signed my name extremely large. This will be second period. Here's bomb diggity. Okay.
Next time.
Let's do a couple of these from our paper, and then we'll go to Covalent. Ready, Freddies? Let me see your beautiful faces. That means look forward. Please. Something. All right, find this on your paper. All right, and as we go, tell me ionic or covalent. First one. Ionic or covalent?
Covalent.
Covalent. Do we know how to name covalent yet? No, I hope you're listening. We don't know how to name covalent yet, so don't mess with the first one. Where is this? Okay. Barium bromide, ionic or covalent? Ionic. So ionic, we can name. We can write the formula for it. So do your business over there and write down the formula for that while my little wheel of death spins. I'm going to tell you that. That's why I'm doing this with you. Give me a hot second. I might just have to orally do this. All right, what'd you get for barium bromide?
BABR2.
BABR2. Good. I don't know how I skipped number 2. How was I doing on the board? I'll just come back here and I'll do this right here.
What is it asking for on the center?
Getting ready to tell you. Hold up. Hold up. Wait a minute. All right, so we got number 3, we just said was barium bromide with a 2 subscript. Look at this, you told me it was ionic, right? Right, so that's going to be Bi, means binary ionic. What does binary refer to? 2. Are there 2 types of elements here? Yes. Okay, so this is a Bi compound, a binary ionic compound. I'm going to go back up to number 2. Formula for number 2, tell me when you're ready.
Fe2, parentheses, CO3, iron 3.
Iron 3 carbonate, good. All right, you see this is ionic, yes? Iron 3 carbonate, definitely, because it says iron 3, which is totally saying iron 3 plus, which is an ion. So we know it's ionic, but is it binary ionic? Are there only 2 types of elements? No, I'm counting iron, carbon, and oxygen. 3 types of elements. That means it's ternary. T here means ternary. It just means more than 2 element types. Ternary. Look at that. That's what the Bi, Bm, and T stand for in the middle. It's just basically classifying the types of compounds. Let's do another one. Number 4. Tin 2 fluoride, ionic or covalent? Huh? Definitely ionic. What's the formula for it?
SM, F2.
F2, because that 2 from tin crossed down. Binary ionic or ternary? Binary ionic, as you see, 1, 2. 2 types of elements. I'm going to do that with you when I get past covalent. Give me 5 minutes. I know, you guys are overachievers. Okay, magnesium oxide.
Ionic.
Formula.
MgO2. No.
HGO. Because magnesium has a 2+ charge, oxygen has a 2- charge, crisscross, they go down to 2 and 2, but guess what? We simplify to 1 and 1. Again, binary ionic. All right, so I think we can practice some of those more later. I'm going to teach you covalent, and then we'll practice them mushed together, because you've got to be able to go back and forth. Ionic, covalent, ionic, covalent. I want to go ahead and get you in that process. So let's do this. Covalent. This is on your paper. You see it? This, at least the subscripts are. You see it in the little box on the top left corner of your paper? Yeah? Okay. Mono means 1. Di means 2. Tri means 3. Tetra means 4. Penta means 5. Hexa means 6. How do you remember that? 6 is spelled with an X. Hexa has an X in it.
Or hexagon.
Or a hexagon, yeah. Hopefully remember geometry a wee bit. Hepta 7. Octa 8. Nona 9. What's 10? Deca 12. Dodeca. What's 11? Me neither. I don't know. Okay. I didn't know somebody else knew. Somebody asked me that first time. I was like,
God. Yeah.
don't let me monotech. I'll have to ask a geometry teacher. Okay, so pretty much covalent is whatever you see, you say. You don't get to do any crisscrossing because there's no charges because they're not ions. They're simply two nonmetals smushed together. But you have multiples of them because sometimes they have to share more electrons than others. So if I say, oh no, you guys tell me, what gas do you breathe out? Carbon dioxide? Why are you saying this di thing? Because there's two oxygens. Why did you not say mono? Why did you not say mono for the carbon?
Because it's assumed.
It's assumed because it sounds stupid to say mono. That's really the reason. If you say mono carbon, I will cut you. Okay, this is not going to work. Okay, that just sounds dumb. That's the only reason you don't say mono in the front. Now, if I said, what's the gas that comes out of your exhaust pipe that will kill you? Carbon monoxide. Why did you say mono?
Yeah, because it's only one oxygen.
Because it's the second element, and you actually have to denote how many of them you have. You don't say mono in the front. You do say mono in the back. So CO, carbon, monoxide. Even though there's one of each, you don't say mono twice. Okay, you say carbon, which indicates one, is assumed, but you just say monoxide to say there's one oxygen. You always have to give a prefix for the back one. You always have to give a prefix other than one for the first one. So if I say da-da-da, da-da-da, what would you say? Diphosphorus? Diphosphorus? Pentoxide. If I say carbon, tetrachloride. Nitrogen dioxide. Sulfur dioxide. So these are really easy. Now, I know they kind of look like polyatomic, so that kind of looks like a polyatomic ion, but how for sure do you know it's not a polyatomic ion? Because there's no what? There's no charge. So if I say if I say this, that's not a covalent compound. That is nitrate. But if I say this, what is it? Nitrogen trioxide. That charge makes a big difference. So please do not just like willy-nilly not write them because I won't know what you're talking about. Okay? So let's do some practice. And this is on your paper? Yeah? This is on your paper? All right. Fast and Furious. CO2. CO. I just did this example.
P2.
P2.
O5.
O5. So whatever the prefix is, it's saying, I have 2 of these. And hey, I have 5 of these. Don't crisscross, don't uncrisscross. Whatever it says, you write. Dinitrogen monoxide. O. Straight O. Silicon dioxide.
SiO2.
SiO2. Carbon tetrabromide.
CaBr4.
CBr4. Sulfur dioxide.
SO2.
SO2. Phosphorus pentabromide.
PBr5.
That's a 5. Okay. Iodine trichloride.
ICL3.
ICL3. I'm not sure why I'm writing my 5s all awkward like. There we go. Nitrogen triiodide.
Ni3.
I3. And if you put like triiodide as a one I there instead of 2, I don't really care. If you spell it wrong, I'll probably understand what you're saying. Just don't like murder it totally with how you spell it. Nitrogen trioxide, dinitrogen trioxide, N2O3. So no crisscrossing. Heck, you don't even have to look at the periodic table unless you forget what one of the symbols is. Okay, so if you recognize that it's non-metal, go straight for the chase. Don't even look at periodic table and make it happen. But you always have to look at the periodic table for ionics. Okay. So let's practice these a bit more. Let's say, who has problem set 9 with them? Okay, I can put it up on the board. Instead of practicing from our worksheet, because this is just a lot of practice, let's kind of kill 2 birds with 1 stone. Let's practice and do problem set 9 at the same time. Okay, so I'll pull it up on the board. You guys do the, as Emma said, let's practice for like 15, 20 minutes, and then we'll do acid nomenclature today. We'll do the acid. And I'm hoping that this thing has stopped. Yep, stopped sticking. So here is problem set 9. I'm not going to, you guys can do that true false stuff later unless you want to do it now. But at least practice these. And I did tell you what BI, VM, and BM. Thank you, Jack. VM just means the same thing as VI, but we're talking about covalent stuff. So if I say CO2, it's C and O. 2 types of elements. That's binary molecular. It's just denoting that's covalent and not ionic. So, for example, silicon dioxide, what's the formula for it? O2. So, right. So SiO2 straight is just Si and oxygen. So 2 types of elements is binary molecular because it's a covalent compound, not an ionic compound. So you guys work on this. I'll play you some jams and ask me questions as you go. Notice I did not put zinc 2 because zinc always has what charge?
1.
No.
Oh.
2. Zinc always has a 2 charge. That's why I don't have to write it because that's a given. There's no question about what zinc is.
I'm feeling Ed Sheeran.
Huh? Ed Sheeran? I can do that. Let's see what we have right now. Actually, let me stop videoing first.
Ed Sheeran is my
From where we left off. Okay. All right, so there's our page. Acid nomenclature. Write down this, and then we'll do some examples with it. And as you're writing this, tell me your favorite acid. Which one do you know? Hydrofluoric. Why do you like hydrofluoric? Because it dissolves bodies. That's why. I was talking to citric acid. Ooh, yummy. That makes our citrus fruits have their different flavors. Hydrofluoric acid, you've probably heard it from biology. But I was working with some graduates from UNCC Friday when we had a snow day, or ice day, or whatever it was. And they said, oh man, we got to take the hydrofluoric acid out of its container because it's eating through the container. Because they didn't know. They can't store it in glass because it eats through glass. They have to store it in this special polymer. So that was fun. And then they have to have like special codes on how to dispose of it. It's pretty wicked. I'll scroll down for you in a second. Okay. Okay, what you should be getting from the first thing is if I say H, you say acid, thank you, or hydrogen, you can say hydrogen, but acids only are the things that denote that it's an acid is if it has a hydrogen in the front, you best bet it is an acid. So if you think acid, you have to tell me it's an acid at some point in time. It's always at the end though, like hydrochloric acid, citric acid, phosphoric acid, hydrofluoric acid, blah, 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 blah. All these things you say acid. The only reason that it is an acid because it has an acidic hydrogen in the front. So H infinity is going to be an acid anytime there's an H in the front. Cool with that. Step 1, recognize it's an acid. Step 2, what kind of acid? Binary acid, ternary acid. What did I tell you binary meant earlier? Huh? Oh, binary, not bi. Bi was referring to the like biphosphate and stuff like that. Binary means 2 in terms of 2 types of elements, right? Because we went through like binary molecular and binary ionic. So 2 types of elements. Guess what one of the elements has to be, guys? It's got to be a hydrogen. And then you get one other element. But of course there's subscripts involved because it's definitely acting ionically. This H in the front right here actually has lost its only electron. So it becomes H1+. So we have to recognize that it acts ionically even though it's just an acid. So what you do is you say whatever your H is bonded to in the name. If it's binary, there's 2 types of elements. The way you tell me it's binary, you don't go, hey, Miss Emma, this one's binary, just BT dubs. You say hydro. I know it sounds silly that this is how you tell me it's binary. But if you say hydro, blah, 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 acid, that means you're telling me it's binary. So if I say HCl, this is hydrochloric acid. So I put chloric right there. So, can you name this one for me? Hydrobromic. Can you name this one? Hydrofluoric. Don't worry about the 2. Name it. Sulfuric, yeah. Hydrosulfuric acid. Okay? It doesn't matter that 2 is there, but tell me, how did that 2 get there?
S has a
2 minus charge, right? So this came to be because I was like, oh, H+, sulfur, crisscross, H2S, yeah.
As water.
Because it actually is an acid, but it's also a base. It's amphoteric. It actually can be acidic and basic. I know, we're going to go over that. Okay, it's just not very strong acid. So you'll see that all of these are binary. How do you know they're all binary? All the ones the examples I've written down.
Are there 2 elements?
Just 2 elements. I don't care how many of the elements I have. I've got, for all of the first examples, I have 1 of each type of element, but then I have 2 hydrogens and 1 sulfur. It's still binary, except 1 type of element in the front and then 1 type of element in the back. So you always say hydro to indicate that it's binary. So let me give you one more example. That one.
Hydrophosphoric acid.
Hydrophosphoric acid. It's cool. You can murder the names a little bit. As long as I hear hydroic acid, I'm good. Okay? Now, if you have a totally different type of acid, it's one that's bigger and better, you've got a ternary acid. That means there's a polyatomic ion involved. They have a little different suffix stuff than what we dealt with over here, okay? Slightly different. So we're going to work on this, and we'll keep working on this again tomorrow. So you don't say hydro, because what did hydro tell us? Binary. This is totally not binary, so don't write hydro. You just go straight to the chase, and you go blah, 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 acid. Say whatever you got to say. So let me tell you how this works. Write down what you need to there, actually, and I'll do an example. So the binary ones are easy because they always have that hydro in the front. You just go with the flow. Hydro does not mean H, because all acids have H's. So it's like, duh, it's going to have an H. It's an acid. But hydro indicates that it's binary. So if you don't say hydro, I'm assuming that it's ternary. I'm assuming it's got a polyatomic ion in it to make it have more than only 2 types of atoms or elements. So this one, I don't say hydro. I go straight to the chase. What I have to do is I have to write down the name of the polyatomic ion with a variation of its ending, and then just say acid. So what polyatomic ion is this?
Sulfate.
Sulfate. Sulfate gets dropped and goes to ic. So this is called sulfuric acid. Okay? Because it sounds weird to say sulfate acid. Yeah? I don't know why. That just feels weird coming out of my mouth. Okay? So what you have to do is come up with a cheesy way to remember how the endings change. And Hollis twins. Remember Hollis twins? This is what they told me my first year teaching. And it just stuck with me because it's hilarious. They went, ick, I ate too much. Because ick and ate go together. Ick, I ate too much. Okay? And then what is, so I'm going to write that down. Ick, ew, I ate too much. Okay. And so then I'm going to change this, and I'm going to do the other version of sulfate, which is this sulfite. Okay, so sulfite is the ite ending, and it changes to os. And they're like, oh, I have tendinitis. Tendinitis. And ick, I ate too much, okay? If you come up with something better than that, I will use you for the next decade. But that's the best I got. Okay, so if you can come up with something better, I'll give you extra credit, because I just feel weird saying this. But ick, I ate too much goes together, ate and ick, and then tendinitis, ite and os go together. But if you know your eights and ites from the polyatomic ion list, you will always remember that. Okay, so how does this change? This first one is sulfate, and we went sulfuric acid. How does this one write?
Sulfurous acid.
Sulfurous acid, right. So, if I say sulfurous acid, in your head you go, oh, os goes with ite, and ite is 1 oxygen less, and then 1 oxygen less is SO3 2 minus, and you pair that with an H, and that's H2SO3. Just like a 5-step process. Yeah. 6-step process, depending on if you know it. So this one's just a little bit more, I guess, like suffix heavy. So you just have to work on it. So this guy is what? C2H3O2. Acetate, right. Acetate, 8 gets changed to
Acetic acid.
ick, right? So acetic acid. Where would you find acetic acid? Hopefully not on the desk. We cleaned. So this is acetate, and we've turned it to acetic acid. Who's a southerner? Southerners? Does anybody put vinegar on their greens. On
I
your
eat
greens.
salt and vinegar chips.
Salt and vinegar chips. Thank you. It's just vinegar. Acetic acid is 5% of vinegar is acetic acid. Okay, that's how you make volcanoes. You guys weren't living as a child? You didn't make baking soda and vinegar? Okay. It's just an acid-base reaction. Makes gases. Okay, what is this one? ClO3, 1 minus.
Chlorate.
Chlorate, yes, yes. Chlorate gets changed to blah in an acid form. Chloric acid. Look at you guys. This is bleach. Chloric acid. What's that sodium hypochlorite in it? But you know it's part of bleach. Okay, let's do some more practice. This is on the back side of your paper. Is this on your paper? I'll just do the ones on your paper then, so we can kind of kill two birds with one stone. Let me pull back up my problem set. My stuff. Okay, so let's do the ones on your paper so we can kind of do both of them. All right, here's what you have. Yes, yes. Okay, so let's go with these first. Let's go with the 16 through blank. Okay. So tell me, ternary or binary first?
Ternary.
How do you know it's ternary?
3 elements.
More than 2. So we have 3 elements going on. So do you say hydro? No. Okay, go straight to the chase. What is that polyatomic ion? Perchlorate, but then you change it to what? Perchloric acid. Thank you. So it was perchlorate. That's what the ClO4 is. But then you went, oh, I gotta change it. Perchloric acid because I ate too much, right?
Where did the third come from?
Because ClO3 is chlorate. And remember when I told you had an extra O? You went up 1. That per means plus 1. It's just a prefix we went over previously. All right, next one, binary, ternary. Ternary, do you say hydro?
Nope.
No. Okay. The PO4 is what?
Phosphate.
Phosphate. So name the acid.
Phosphoric acid.
Phosphoric acid. Right, because 8 went to ic. Next one, 18. Binary, ternary. Binary. What do you say to tell me it's binary?
Because it only has 2 elements.
I mean, what prefix do you say to tell me it's binary?
Oh, hydrogen.
Hydro. So hydro means it's binary. And then what? Chloric acid. So what is always going to be kind of the, I say hydrochloric. What's always going to be the ending of the nonmetal in a binary acid? It always is the ic. Do not try to mess with that. Okay, it's always ic. So let's do another binary. Choose one. 21. What do I say? Hydroiodic acid. It just sounds like I'm just throwing syllables out there, but I'm not. Hydroiodic acid. Tell me another binary one.
HF.
23? Okay, 23. Hydrochloric. I think the U comes before the O. Acid. Yeah, it's weird. It's okay. I had a chemistry teacher who used to do spelling tests and I despised it. I was like, who really cares? I can do the chemistry. Do I have to spell it right? Nah. Okay, let's do 19. 19, do I say hydro? No. Okay, straight to the chase. What is this guy?
Sulfate.
Sulfate goes to?
Uric.
I know it sounds weird. We had to go from sulfate to sulfuric, but you go sulfuric acid. Okay, next one down. What is the NO2?
Nitrous. Maybe?
It is nitrous, okay, but hold on. That NO2 is nitrite, yeah? Nitrite goes to ose in the acid form, so what's the name of this? Nitrous acid. And somebody asked me one time, is that what they put in nitrous, like in cars? And I still don't know. I have not looked that up yet.
Nitrous oxide.
Nitrous oxide, thank you. I know how to drift, but that's about it, so. Okay. Yeah. I do it in the snow mainly. It's not very often. Okay, this one, 22.
Acetic.
Right, so that was acetate. You went acetate to ic, so acetic acid. Okay, we exhausted the writing of it. Let's try to give the formula for it. That means you have to do some crisscrossing because these are acting as if they're ionic, okay? So, first thing you notice is you don't see a web. You don't see hydro, so what do you already know about it? It is ternary, so that means we have a what involved? Polyatomic ion. I like you can read my mind. Good job. Okay, that's a polyatomic ion. Which one? Say again?
Nitrate.
Nitrate. So that's NO SO3, 1 minus, and then always your other element involved is hydrogen. Crisscross, what do you get?
HNO3.
HNO3. Good job. Let's go down to 4. 4, what do you automatically see? Hydro, what's it telling you?
2 elements.
2 elements, binary, no crazy polyatomics in here. What's definitely the first one, guys? Hydrogen. What's definitely the second one? Bromine, what's bromine's charge? We're struggling. Is it 1? Okay. Br 1 minus, right? Because it's in the 7th group. Jump up 1. Overall, this is BHBr. Let's do 2 more. Let's do 5. Sulfurous acid. So what does that tell you by seeing that there's no hydro? It's ternary, so what's involved? Polyatomic, which one?
Sulfite.
Sulfite. I don't know who said it, thank you. Sulfite, because it's tendinitis, right? So ite goes with the O, so that's sulfite. What's sulfite's formula? SO3. 2 minus, okay. H is in the front, so H, SO3 gets a parentheses because it's a polyatomic. And then, what's it? H2 what? SO3, okay? How? It doesn't say IT, but if you read between the lines, it does say IT because you have to know the previous rules of the acids. Previous rules of acids are that eights and X go together and ites and oses go together. So if you say ose, you think ite. If you say ick, you think eight. I know it sounds like I'm throwing out words, but I'm not. Okay, let's do 2. Let's do 1 more. Let's do. Pick one. Oh no, I picked it. 14. I'll do 14. Carbonic acid. What's it? What do you? Tell me your thought process. Ternary. Okay, so it came from 8. So carbonate is what? CO3. 2 minus? 2 minus, yeah. Okay. And then H is just H plus. Put it together, what do you get?
H2CO3.
H2CO3. This is carbonated water, seltzer water. Ew. I know.
Wait, it's an acid.
It's an acid.
That's like the main acid we talked about in hunger. It's like all we talk about.
Yeah. Well, because it's in everything. If you set out a cup of water, carbon dioxide will become dissolved in it, and it will become acidic. So I can take the pH of water day 1, it'll be approximately 7, except for my DI water, which was really acidic. I don't know why. But it'll be about 7. But if you leave it out overnight, it'll go about 6, and maybe another night you go about pH of 5. So it's going down because it's getting more acidic. It won't go to like pH 1. Don't be scared. Like you can leave water around. It's not going to be deadly.
Soft drinks are bad.
Yeah, because they eat away at your enamel, and also you've got this bacteria in your mouth, like lactobacillus. I can't remember the last bit of it. Lactobacillus loves acid and sugar, and if you eat a lot of sugar and you don't brush your teeth, the acid eats it, eats the sugar, poops out acid, makes your teeth degrade because it's pooping acid on your teeth.
Yeah.
Yeah, makes your breath smell bad too. So, fun fact for the day. Okay, we have 4 minutes. Do some nomenclature. Oh no, I have extra credit planned for you. Ready?
Yeah.
Okay, you have to raise your hand. I did this my first period. They're like, we could do this all day. And I was like, okay, I'll do this. I can do this. No sheets. No sheets. If you want to participate. If not, do reading guide 9. Problem set 9. Raise your hand when you're ready. You have to name this. 3, 2, 1. Raise your hand.
Oh wait, nitrate.
Nitrate. Good.
Aw, Benny.
Okay, that's 1 point. Okay, 3, 2, 1.
Upside.
Oh my gosh, hydroxide. Good. Okay, let's go. 3, 2, 1.
Sulfite. I said it. Sulfite. Sulfite.
No, sulfite. Okay, Benny, scoot over here. Get over here. Okay. Sulfite. These are just polyatomics. Just polyatomics.
Cyanide.
What's the list? Cyanide.
Oh,
No, I'm not. I'm watching.
Look over, man.
I'm watching. I got this. That's a 2. You know what that is?
No. You know?
No.
Wait, no, that's not. I don't even know that word.
What, Miss
I was
Emma?
gonna say sulfate.
Bisulfate. I don't know.
Biosulfate. Good job, Miss Emma. What? Awesome. Okay, I get 1 point. Biosulfate. It's a hard
Iron
one.
excess.
Okay.
Acetone. Or
Wait.
acetone.
Again? Jeremiah, acetate. Okay, that's just straight acetate. You had it. I'm coming back to you, Vinny. Just wait.
I said acetone for some reason. What is that? Phosphate.
Phosphite. There we go, 18.
Oh,
Okay,
well,
but yes, good job. We had phosphite.
Sulfide.
What'd you
Sulfide.
say? Sulfide. Okay, I'll give.
Wait,
I'll give half. Sulfide. I'll give half. Because I have 2 answers. Okay.
Just like shout out like 2.
Penny, how do you already know all of these?
Sulfuric acid.
Bisulfate.
Oh, wait.
Fate. Bisulfate. Okay.
Oh, that's not acid.
No, it's not. I know you gotta see. These are all polyatomic.
Oh, right.
Sitting in the front.
Yeah, I'm hungry. Carbonic acid. No, that's
No.
not carbonate. Carbonate.
Carbonate. Thank
Dang
you.
it.
Okay. Now, Benny, come on up. You're the master. Let's do this. Yeah. Somebody else volunteer. Yeah, I mean, you raise your hand. That's what I'm saying. Give me some examples. You got this.
Oh, just random
Throw out
examples. Okay.
Everybody. Phosphate. You just said that. Lewis. Okay, Lewis gets a point. Shout it out on this one. Where's Lewis? He's right there. Give him a point. I'll have time for one more. One more. Go. I know. Hide it. You have to be sneaky.
I don't hide it very well. Well, he said I dropped it.
I dropped that. We got this. Okay, is it time?
Nick.
It's that time. Please do sum of problem set 9. It's in your best interest because it's due Thursday.
Wait, Nick
Yeah,
got a
yeah.
point.
Oh, Nick. I have to write these down.
Let's see.
Thanks. Yay! Bye, guys. Had a good class.